Hello friends, myself Jinder Kumar. I am taking lecture nursing for the mechanical engineering student. In continuation of the previous lecture, now we will discuss about the speed control of induction motor. This will be the last topic of the three-phase induction motor. A three-phase induction motor is basically a constant speed motor, so it's somewhat difficult to control its speed. The speed control of induction motor is done at the cost of decreasing efficiency and low electrical power factor. Before discussing the methods to control the speed of three-phase induction motor, one should know the basic formulas of speed and torque of three-phase induction motor, as the methods of speed control depends upon these formulas. There will be a synchronous speed which is indicated by the n is equal to 120 f by p, where f is the frequency and p is the number of poles. The speed of induction motor is given by n equal to ns into 1 minus s, where n is the speed of the rotor of an induction motor and ns is the synchronous speed, s is the slip. The torque produced by three-phase induction motor is given by T equal to 3 upon 2 pi ns into square R2 into upon R2 square plus Sx to the whole square. When the rotor is at standstill, slip S is equal to 1 because the ns minus nr equal to, both are the equal. Rotor is n equal to 0. So ns upon ns equal to 1. ns upon ns equal to 1. So the slip at standstill equal to 1. So the equation of the torque equally converted, that there is a slip equal to 1. So entire equation will be T equal to 3 upon 2 pi ns dt square R2 upon R2 square plus x to the whole square, where V2 is the rotor EMF, ns is the synchronous speed, R2 is the rotor resistance, x is the rotor inductive reactance. The speed of induction motor is changed from both stator and rotor side. The speed control of three-phase induction motor from stator side are further classified as V by F control or frequency control, changing the number of stator poles, controlling the supply voltage, adding rheostat in the stator circuit. The speed control of three-phase induction motor from rotor side are further classified as adding external resistance on rotor side, cascade control method, injecting slip frequency EMF into rotor side. Initially, we are looking over the V by F control by F will be performed on the stator side by V by F control or frequency control, or controlling the supply voltages. Changing the number of stator poles is the another method. In stator poles can be changed by two methods. First is the multiple stator winding method. In this method of speed control of three-phase induction motor, we provide two separate windings in the stator. These two stator windings are electrically isolated from each other and are bound for two different number of poles using a switching arrangement. At a time, supply is given to one winding only and hence speed control is possible. Disadvantages of this method are that the speed control is not possible in this field. This method is more costly and less efficient as two different stator windings are required. This method of speed control can only be applied to squirrel cage type induction motor only. Next is the pole amplitude modulation method, or PAM method. In this method of speed control of three-phase induction motor, the original sinusoidal MMF wave is modulated by another sinusoidal MMF wave having the different number of poles. So the speed can be varied by as the number of poles of the machine will be changes. So the speed of the induction motor will be changes as the change by the PAM method. Next is the adding rheostat in stator circuit. In this method of speed control of three-phase induction motor, rheostat is added in stator circuit. Due to this, voltage gets dropped. In case of three-phase induction motor, torque produced is given by T is directly proportional to SVT square. If we decrease supply voltage, torque will also decrease, but for supplying the same load, the torque must remain the same. And it is only possible if we increase the slip. And if the slip increase, motor will run, reduce the speed. Next method is the adding external resistance on rotor side. Now the previous method is related to the stator side. Now the method is related to the rotor side. In this method of speed control of three-phase induction motor, external resistance are added on rotor side. The three-phase induction motor operates in a low slip region. In low slip region means Sx square becomes very small as compared to R2. So it can be neglected and also E2 is constant. Now if we increase the rotor resistance, R2 torque decreases, but to supply the same load torque must remain constant. So we increase the slip, which will further result in the decreasing rotor speed. Thus by adding additional resistance in the rotor circuit, we can decrease the speed of the three-phase induction motor. The main advantage of this method is that with an addition of external resistance, starting torque increases. But this method of speed control of three-phase induction motor also suffers from some disadvantages. And these disadvantages are: first, the speed above the normal value is not possible. Second, large speed change requires a large value of resistance, and if such large value of resistance is added in a circuit, it causes large copper losses and hence reduction in efficiency. So we have to compensate all that with the efficiency. Next, presence of resistance causes more losses. Next, this method cannot be used for the squirrel cage type induction motor because in squirrel cage there is a cage and we have done the connection to provide the external resistance at the rotor side. Next is the cascade control method. In this method of speed control of three-phase induction motor, the two three-phase induction motors are connected on a common shaft and hence called cascaded motor. One motor is called the main motor, another motor is called the auxiliary motor. The three-phase supply is given to the stator of the main motor while the auxiliary motor is derived at a slip frequency from the slip ring of the main motor. Next is the injecting slip frequency EMF into rotor side. When the speed control of three-phase induction motor is done by adding resistance in rotor circuit, some part of power called the slip power is lost as I square R losses. Therefore, the efficiency of three-phase induction motor is reduced by this method of speed control. This slip power loss can be recovered and supplied back to improve the overall efficiency of the three-phase induction motor, and this scheme of recovering the power is called slip power recovery scheme. And this is done by connecting an external source of EMF of supply of slip frequency to the rotor circuit. The injected EMF can either oppose the rotor induced EMF or aids the rotor induced EMF. If it opposes the rotor induced EMF, the total rotor resistance increases and hence the speed is decreased. And if the injected EMF aids the main rotor EMF, the total decreases and hence speed increases. Therefore, by injecting induced EMF in the rotor circuit, the speed can be easily controlled. The main advantage of this type of speed control of three-phase induction motor is that a wide range of speed control is possible, whether it is above normal or below normal speed. These are the different types of speed control method which can be applicable for the three-phase induction motor which we are discussing under this heading. And thank you for attending the lecture, and this is the end of the